Hello and welcome. So, this is still the same lecture. I think the way I see it, this should be like the third part. The first thing you should have done was, the solution to last week's homework. And then the next part was the introduction to like for loops and lists. Alright, and so we left off with this, which was a list of random numbers, and we did some things. If this made sense to you, then you're in great shape. If this didn't make sense to you, well, we're going to do quite a few more examples before the week's over with, and there's a lab, and there's an assignment, so you have no choice but, well, I mean, I guess you could just not do all the stuff that's assigned for the week, but if you do the stuff that's assigned for the week, you're going to get practice. It's going to come together more. I mean, unless you just don't do your end of it, which is watching the lecture and the lab solutions, which some you might, but anyways. So this was random numbers. Now we're going to be looking at a list full of strings. And we're going to be doing this a bunch. So this is this one and the next one. So if this made sense to you, great. You're halfway there. Maybe 2/3 of the way there. If this didn't make sense to you, well, you do get a bunch more chances at kind of picking it up. This is the easier one, I'd say, because you just got a list of numbers. Here you got a list of strings. And strings are a little complicated because strings are complicated, right? They have properties and functions. So I'm going to work with this planets list. So that planets list is here. You see in week 8 I posted it. Right, so there's planets, lists, or there's planets, dates, and countries. The other thing I'll mention, so I download this. I'll open it up in a second. I think of this lecture as having like 4 parts. There was the first part where you watch the solution to last week's homework. Right, if you didn't understand last week's homework, then this week is not going to go well for you, which is why I gave you a solution video, which I'm saying is mandatory watching as part of the lecture. That was part 1. Part 2 was, this part where we talked a lot about loops and lists, and I showed you the numeric ones. There's this part where we do like lists of strings, and then there's the last part where we start looking at more complicated things, which are dictionaries. So this is like the third of 4 parts. All right, I've set it up, talked about it. What I need to do now is open up that file that I downloaded. That's going to take a minute, so I'm going to pause it, and when you see my screen, I'll have that planets file in here. Alright, so here it is in downloads. I don't remember how this works. I haven't done this in a while. I'm just opening it. So for me, it's going to open up in Thonny. See, it opens up as a new tab. Can I run it? I can run it. Alright, nothing happens. Alright, so this is a list called planets, and it's got a bunch of strings in it. Right, so it's different from what we did before, because what we did before is we made this random list of numbers. Now we're going to be processing strings. And I said, and really this planets and states, in my mind, the person who, knows the big plan and has done this before, I understand that these are like the same problems. They're just the same kind of problems on a different list. On this one, I said we're going to use a while loop. On this one, we're going to use a for loop. And so I think by the end of this little demonstration, you're going to go, oh yeah, for loops are easier. So remember when I was doing this here, I kept doing for loops, because why not when you're working with a list? But here I'm going to do a while loop, just so you can kind of compare and contrast what those two things look like. So I got this list. I want to display the names of the planets. Right, when I say this, this means use a while loop, right? Use a while loop too. Some people just do some weird stuff where they just print them out. Trust me, I've seen on like exams where people go print planets 1. Don't do this. This is not what I'm telling you to do. I was trying to copy and paste it. Can you imagine, right? Like, I don't know, is there what's in here? All right, so you see, like, technically that is printing all the list of, you can do that 9 times or 8 times. That is not use a while loop. So use a while loop. All right, so if I'm going to use a while loop, that means I need a counter. So I'll say I equals 0. Why not start at 0? While I is what, right? Here's where it gets interesting. So how many things are in this list? I mean, you could count and go 1, 2, 3, 4, 5, 6, 7. What? 1, 2, 3, 4, 5, 6, 7, 8. Counting's hard. You could say, while I is less than 8. You could do that. I'm telling you that is not the right way to do this. Do you know how easy it would be? Right, this is a data file. I could give you a list with so many things in it that you'd spend an hour counting them all. And even worse than spending an hour counting them all is knowing the fact that you're probably going to miscount them. You remember when I miscounted these? I was like, 7. That doesn't sound right. This is bad. This is what you call hard coding. When you got a list, you should just pretend you don't know anything about it. So don't do that. Instead, go len of planets. Right? Let the computer count for you. That's what one of the things computers are good at is counting. So I don't know how long it is, but you see how this code is not reliant on this, right? Is Pluto in there? Is Pluto not in there? Is the person making this list an idiot? I mean, right? I mean, who's to say that the list doesn't have Earth in it? So don't make assumptions and just do it like this. This is how you want to do it. And at this point, you might already be like, oh yeah, now I see why for loops are cool. And so I'm going to say print. And what do I want to print out? I want to print out the thing in planets in spot I. Right? So it starts off as being the thing in spot 0. I'll show you. So it's going to be, starts off in 0. So it's going to print out the thing in spot 0. Then it's, oh, I forgot to increment my counter. Right? So I add 1 to my counter. So it starts off printing the thing in spot 0, then the thing in spot 1, then the thing in spot 2, then the thing in spot 3. Eventually it gets to spot 9 or 8, which is out of bounds, and it'll break out of the loop. And it printed Mercury through Neptune. So when you're doing these list problems, my best tip for you is make sure that it gets the first one and the last one, right? There's no good reason why it would skip anything in the middle, right? And if you mess up, I'll show you like what a mess up would be. Like if you start at 1, well, then you're going to miss Mercury. Do you see? And so most loop problems, you either are off a little at the beginning or the end. I don't know. I'm trying to think how else you could do this. Like, I guess another mistake would be like if you did less than or equal to, then it should crash because you go out of range. But so when you're checking these, just make sure the first thing's in there and there's the last thing's in there. That's it, right? That's how you print a list. And so you see this prints any list. The only thing that changes is the name of the list, right? You might be making some assumptions about, this is the planets in our solar system. Who said this is our solar system? Maybe this is all the planets in the galaxy. I don't know what it is, and it doesn't matter. If you write code like this, it doesn't matter. However many things is in here is how it's going to work. All right, so display the names of the planets. How many planets have an E in their name? Okay, well, let's do that one. All right, if I'm going to do that one, I need to reset my counter to 0 because it got up to 8. And then I'll say while I is less than the len of planets. And if you start to realize that these things kind of have a lot of repetition going on, kind of the same or similar, well, yes, they are. To me, they're pretty boring because it's like, oh, okay, iterating over a list, iterating over a list. Exact same setup. It is important that I reset it to 0 because it got up to 8 and then it broke out of that loop. If I don't reset it, then I is still going to be at 8. So I have to reset it. Or I could go, hey, okay, I already used I. I'm going to call this one J. Remember, if you're out of I's, then call it J. But that also being said, there's no reason why I couldn't just reuse that same variable and just make sure to reset it. So this right here is going to go through the list, but I don't want to just go through the list. I want to see how many things have an E in them. So how the heck do I figure out if there's an E? Well, if you're counting how many of something there is, then that means you need an accumulator. So I'll say E planets, right? E planets equals 0. And I want to camel case that. This is the number of planets that have an E in them. Planets. So this is an accumulator. And so this one is a conditional statement because I want to figure out if it has an E in it. So how do I do that? So how do I figure out if the planet has an E in it? Well, I'm going to say this is a good time for the in operator. So I'll say if E in planets I, right, that means the current planet, then E planets plus equals 1. Right, so here there was no conditional statement. I was just going through all of them and printing them out. Here I'm looking at each planet and I'm saying, does that planet have an E in it? If it does, add 1 to planets and then increment I. And then I want to print out my results here after the loop. Number of planets with an E. I have to do the whole stringify. E planets. And let's see if it works. 4, it says. Do I agree? 1, 2, 3, 4, 5. Right? So why does that say that, right? That seems That seems weird. So do you... Okay, so here's the thing. That is true. There is only 4 with an E, but there is 5 with an E. Why is that? Well, because that's a capital E. That's not a lowercase e. That's you making an assumption. There is only 4 planets in that list with a lowercase e in their name. Right? That is not in lowercase e. So this is correct. While it's not intuitive, it is not your business to make assumptions and be intuitive. I mean, this is writing a program that counts the number of planets with an E in it. So notice, I'm sure this part hangs people up, but what does that mean? That means the thing in spot I in the list called planets. You get it. I know you do, because it's the exact same thing as slicing strings, right? This is like the thing in spot 0, the thing in spot 1, the thing in spot 2. You've been working with lists and strings for a while now, and this isn't different. This is the thing that people struggle with. This is meaning like the thing in spot I, right? And counter is how we represent spot I. Which planet has the longest name? All right, so this one's more difficult. This is just a max problem. And I want to compare this to this at this point. So print, right? Same thing. It's just strings instead of a list. We're using a while loop instead of a for loop. You know, how many have an E in them? That's kind of similar to how many are greater than 50, right? We had a search criteria we were looking for. If that criteria was met, then we incremented an accumulator. What's the maximum value? Well, there's no maximums in a list of strings. All there is the longest name. So this is a pretty tough one. So I'll show you how it works. All right. So a max works the same way it worked over here. You gotta make a variable for your max and initialize it to the first thing. That's what you want to do. So I'll say max equals planets thing in spot 0. There's only one rational way to do this. Well, I mean, that's the most rational way to do it, is just initialize your max to whatever the first thing in the list is. And now I'm going to need a counter, right? I equals 0. While I is less than the len of planets. I'm sure some of you are having a hard time following along. Stop worrying about how confused you are. You're halfway through the lecture. I know I'm getting on you, and I can't even see you, and I'm doing this preemptively. I just taught before. I know people just start quitting immediately. Oh, this is complicated. I don't follow. That's why I'm doing like 6, 7 examples in a row, and that's why the lab is a bunch more examples, and the homework's a bunch more examples. It doesn't matter if it's not super intuitive to you or it's kind of confusing. What you should be realizing is, oh, there are some similarities between these things. So stop getting frustrated and know that you can do this. Because if you don't believe that you can do it, well, then you can't do it. And that's on you, not anyone else. There's nothing I can do about that if you are thinking that this is getting too complicated for you. You can do this. All right, so this is just the generic function for iterating over planets. You notice this doesn't change. The only thing that changes is this stuff right here. And so I'm going to do it similar to how I did it before. So if we're looking for a max. Now this one's kind of tricky. So we need to grab, so we'll say if the planet's spot I is greater than max. Kind of. That's kind of what we want to do. I'm telling you that's not really what we want to do, but it's kind of what we want to do. Equals planets I. That's kind of what we want to do. But the problem here is, like, I actually don't know what that's going to do. I know it's wrong, but let's just see what it'll do. I'm kind of interested to see. Longest planet. And you don't need to stringify this because this is already a string. Let's see what it says the longest planet is. I don't know what it's going to say. It says it's Venus, right? So Venus is not the longest planet, so it's like, well, here's the interesting thing. It's this line right here. That's the weird part. So what does that mean? Comparing one planet to another. Well, what it means is, like, if you just compare one string to another, it's going to compare them alphabetically. And so what it's telling you is that V comes last in the alphabet. Which, oh, that's not what I wanted. What you wanted was the length of those strings. You didn't want to compare, like, what comes later in the alphabet. You wanted the length. So it's an easy fix. You want to compare the length of that planet to the length of the max. Right? You were just comparing things. Like, you were kind of comparing the right things, but you weren't comparing the right parts of them. That's where I say strings are complicated. Right over here, it was just, oh, right? I mean, you didn't have to say the length of the things. You just straight up compared them because all they were is numbers. But when those things you're talking about are strings, well, how do you want to compare them? And so here it says the longest planet name is Mercury, which is probably true. Mercury has 7 characters long. Jupiter is 7 characters long. So there's more than one planet that's 7 characters long. What one do you think it should be? Should it be Jupiter or should it be Mercury? It doesn't matter. There's no way to account for that, really. The way this is written, though, is it's looking for one to be longer. If you want it to be the last one, then you would change this to a greater than or equal to. But as you see, it doesn't matter. I mean, some people, I've seen people on this problem be like, oh, they want to make a list and say all the planets that are, that length. That is not the problem. If you want to do something cool like that, go ahead. But it's not the problem. I don't care what one you return. It doesn't matter to me whether you return the first one or the last one. It's not false that Mercury is the longest planet name. It's just true that there's more than one planet that's that long. Alright, so again, want to reflect on. It's pretty much the same kind of, I mean, the one of the key differences is that these were for loops. But these problems are very similar to these problems, just the difference is we're comparing strings here. With that being said, let's move on to states. So on states, I'm going to do the same kind of problems, but what I'm going to do is I'm going to use a for loop on them. So these are the same kind of problems. So how many states start with new? So, right, so that's a search one. Display the names of the states that start with an O. That's a search one. How many states have an E in their name? That's a search one. Which state has the longest name? That's a search one. Specifically, that's a max one. This is an accumulator. This is just print. This is an accumulator, and this is a max problem. What you need to be working on is figuring out what these have in common. So like over here, this is just a print one. This is an accumulator. This is a max problem. Over here, this is a print problem. This is an accumulator problem. This is a max problem. This one was different, right? Average was kind of different. I don't know how to characterize that one. It was a little different. All right, so I'm gonna go get that file, and I'll meet you back here in Thonny in a minute. And when I say meet you back here, I mean download it, go here, open it up. Now I got a new tab. I thought I opened. I don't know what I opened. Did I open? Oh, okay. I opened planets again. All right, so now I got states. Oh, I got some junk in here. Well, I'll get rid of that. I didn't mean that for... Well, it won't be there for you, but it was there for me. So here's state names. You might think you know the states. You don't know the states. You don't know what's in here. I mean, who thought American Samoa was going to be in here? Do you know that Oregon's in here? When you're getting a list from someone, you don't know what's in it. So don't make the mistake of thinking there's 50 things in here, because there's not 50 things in here. There's stuff in here that you probably aren't expecting to be in there. There might be some stuff that's not in. You don't know what's in there. All right, keep that in mind. Now let's go do some for loops. So first one is we're going to see how many states start with new. All right, so we got state names as the name of our array. So not going to do while loops this time. I also want to point out, could I have done for loops on these? Yes. Would it have made it easier? Yes. You're about to appreciate why for loops are useful for working on a list. So if I'm going to do a for loop, I don't need a counter. I just jump straight into the for, and then I got to make up a name. So I'll call it state because these are states. For state in state names. No counters, right? I mean, I could have done this just like this with a counter and a while loop, but like I said, for loops are useful for lists. Also, I'll say it for the 10th time, don't get too attached to for loops. For loops are great for lists. They're not great for a lot of other things. All right, for state in names. I want to figure out what ones start with new, so how do I write that code? I'll say if state, notice I don't have to say like state names I just say state. That's one of the big upsides to these for each loops. So if state, I want to look at the first 3 characters, so I'm going to slice it. How about 0, 3, right? That's how you slice a string, is equal to new. Then, what am I doing? Counting them or printing them? I'm counting them, which means I need an accumulator. So I'll say new states equals 0. So I create my accumulator. If it does start, if the first 3 characters are new, then I say new states equals new states plus 1. There's no else. It's just move on, right? It either starts with new or it doesn't. And then at the end, I print, right? Outside of the loop, I say new states. This is going to be one of those where I have to stringify it because it's a number. Close, close, and let's see. How many states start with new? 4? I don't know. You could check it because they are alphabetical. So we got New Hampshire, New Jersey, New Mexico, and New York. Isn't that weird? Like, why are they not in the order? I don't know. But that's kind of my point. I don't know what's in this list. I didn't make this list. And you didn't make this list. So it doesn't matter how many things are in it. Just write the code. All right. Display the names of all the states that start with an O. So on this one, this is not an accumulator. I don't need an accumulator. It's just a print one. So I'll do a for loop for state in state names if, and here you got to know how to slice a string again. So if you want to look at the first character, I'll say if state 0 equals O. I think that's what I said I was doing, right? I don't know the prompts any better than you. Well, a little bit. Okay? If it starts with O, then print state. I do not need to turn it into a string. I do not need to increment any counters. That's it. Either it starts with an O. Oh, yeah, okay, sorry. Looks good. Equal. I meant equal. Ohio, Oklahoma, Oregon. I don't know. I believe it. I mean, I have no reason to think that it doesn't work. Right, so you see how nice this for loop is for iterating over a structure? Compare that with like what this would have looked like over here. Right? Initialize the counter. I have to index into the list, and I have to increment the counter. I don't have to worry about any of that with the for loop. How many states have an E in their name? Now this is a good one to compare. And so this one's an accumulator, so I'll call it E states again. I'll initialize it to 0. For, I don't know, just to be weird, I'll call it ST this time, which makes no sense, but I'll do it. I'm trying to show you that you can call it what you want to call it. If E in ST, and that's a bad variable name, by the way. I'm just trying to show you that you can call it whatever you want. Because trust me when I say that there's people who watch these videos and they're trying to make notes and then they just start... I don't know how to explain it. They think that this becomes a copy-paste exercise. Like, oh, this is always called state. It's not. It's called whatever you want to call it. And I will make a point for you. A lot of you are not going to like this, but I will. It's one of the best things one of the best pieces of advice I can give you about programming. One is don't copy and paste. Don't do it. That's the worst way to learn. The other is your notes probably are not helpful. I've taught many people to program. I'm a pretty good programming teacher. Sorry to be not humble about that, but I know I've taught a lot of people to program, and I've seen the notes that they make. The notes don't make sense. They're oftentimes just copying stuff down, and they don't make a lot of sense. The only way to really get better at programming is to just write code and play around with it. And copying doesn't do that for you. And I cannot imagine what kind of notes you would actually make that would be helpful. I've seen people trying to write notes, and I will tell you that the people that struggle, a lot of the ones that struggle, I mean, a lot of them just don't put in the time and don't watch the videos and don't do the things. But there are people that do put in the effort, and the ones that struggle the most usually have a bunch of notes. They're expecting there to be an answer in their notes. There's not an answer. Every one of these problems is unique. And every one of these problems has something in common with all the other ones, but they're all unique. And so that's why I do weird things like that. So you don't think that, oh, that should be called state. Trust me, no one recognizes it more than me when I'm grading like an exam or a quiz, and I know that what you did was copy and paste some answer from something else and try and modify it. That is just a really bad way to go about it. Let me print out these results. Number of states with an E in them. E states. I know I just spent like 2 minutes ridiculing people. It's not really my goal. I'm just trying to help. Oh, that needs to be stringified. The reason I change up my variable names and change the way I do things is so you understand that there's not an answer. There's many answers. There's many ways to do it. This is the only thing that you have any choice in. That's a keyword. That's a keyword. That's the name of the list. That's a key symbol. That's a variable name that you made up. Remember back when we started doing this, I said, if people can't figure out what their variable names are and why they did them, well, then programming is not going to go well for you. Because there are parts of this that are negotiable, like, am I going to use a while loop? Am I going to use a for loop? What's this called? What's this called? And there's parts that aren't going to change. And the last one, which state has the longest name? All right, so this one, also let's compare this one here with this one here, because these are very similar, right? So notice I didn't have any reference to a counter. I didn't have to initialize it. I didn't have to say anything here. I didn't have to increment it. I didn't have to say planet's eye. Here I just said ST, right? So I didn't have to reference that counter at all. And this last one where I say what's the longest state, this one's actually going to be just like this one. It's just for loop instead, which is going to be nice. So that said, if you're going to do one of these, you're going to need a max, and you should always initialize it to the first thing. It doesn't make any sense to initialize it to anything else. So state name 0, that's my max. Now I'll jump into my for loop for, just trying to be weird now, the state. Right? Here's that part where I said I'm just changing it up. So you understand that some parts of this are negotiable and some are not. And so now it's a max problem. So if len of the state is greater than len of max, then max equals the state. There's no else. It's just move on, right? You either do a swap or you don't. And at the end, I'll say the longest state is concatenate, and I can say max. Because it's a string, I don't need to turn it into a string, right? It's the reason I have to do this is when the thing was a number, right? Because I'm doing math with it, and then I need to turn it into a string. If it starts out as a string, then I don't need to change anything. So I run this, and it says the longest state is American Samoa. I could believe that. That's a pretty long name. Is there any ties? I don't know. And I'll be honest with you, I don't care. I'm sure, I mean, if there is a title, so I put an equal in there. Let's just see if there's more than one. Oh, sure, Virgin Islands. Seems about right. So what one of those gets returned doesn't matter. Like this means return the name of the first state with the maximum length. This means the last state in the list with that length. It doesn't matter what one you return. Look, you could print out all the states with that length, but that's not what the problem says to do. It wouldn't be wrong if you did that, but it's just a different problem. And so if you're like, oh, I like this is cool, then yeah, figure out a way to do that. But I'm always trying to think about those people who are struggling with this. My priority is the people who are struggling to get their head wrapped around this, and I'm not trying to make it more complicated just because it needs to be more complicated. I'm doing tons of examples, and I'm like pleading with you because I know some people. I know how this goes. I know some people are right at that point where they're about ready to, like they're mentally almost kind of checking out. They're thinking, oh, this is getting too complicated. I can't do this. You can do this. If you start telling yourself you can't, then you're done. But you can do this. I know things are getting complicated. I know that. Things don't really get much any more complicated than this, so well, actually, that's not true, that we got to do dictionaries, but trust me, I won't get carried away with dictionaries. All right, so this was part 3 of the stuff I expect you to watch for the week. Next up is a bunch of stuff, right? We'll talk about, you'll see. It's the one more part of this lecture coming up. Hang in there. You can do it.